Hi and welcome to this Edexcel GCSE prediction of Paper 2 for the higher paper from onmaths.com. This is done after Paper 1. Enjoy! Hi, I'm Chris Gilpin and welcome to this prediction from onmaths.com for Paper 2. So hopefully you found Paper 1 interesting. I know that the last question has generated an awful lot of discussion. We knew that the grade 9 is above A star, so we know that there are going to be questions on the paper that are harder than the traditional old A star questions. So we just need to be prepared for that. If you're looking for for a grade 9, chances are you don't need to ace that one question. That getting that one question wrong won't stop you from getting a grade 9. It just means you need to do a lot better in the rest of the paper. So if you panicked and thought, oh, I need a grade 9, I didn't quite get that last question, just focus on the ones you did get. And don't forget, this is the only year, this is the first year that you are all competing against each other. So if you found something difficult and everyone else found it difficult, then the grade boundaries will reflect that. So take comfort. You've got 2/3 of the marks still to get. So if you think you did really badly in Paper 1, you've still got so many more marks to pick it up. In the mocks that we ran, a lot of students did really badly in Paper 1 and still ended up getting the grade they wanted from the other two papers. You have the comfort now of having a calculator, so if you're doing anything without a calculator, do it with a calculator. You will have one of these for the next two papers, so use it for everything. Every calculation you do, use the calculator. Obviously, if it can be done on the calculator. So if I ask you to draw a graph, well, the calculators that we've got or that we can use aren't very good at drawing graphs. Okay, so how did I create the Paper 2 prediction? Well, what I did was I removed all the topics from Paper 1, and so we're ignoring those. Now, be careful with that because they can still come up. Things like ratio and proportion are almost certainly coming up again, so that takes a backseat a little bit, but we've got to just remember they might still come up, so still revise them. And I've looked at the remaining topics, taken out the non-calculator ones, the traditional non-calculator questions, so you won't be asked to multiply two numbers together or whatever it is, because we've got a calculator, so it's too easy. So I've taken those out and I've looked at what's left. Now, obviously Paper 2 and Paper 3 are pretty much the same paper. In fact, in the early drafts, I believe Edexcel, AQA and OCR wanted just two papers and one really super duper paper. But they realised that people sitting there for 3 hours, 4 hours, whatever it was going to be, is just going to be too long. So what they've done is they've split them up into two, but they're equal papers. There's no difference between the papers, and that's really important to realise. So we look at the Paper 2 and Paper 3 and I think, right, okay, I think these topics are likely to come up together and these topics are likely to come up together. Now, I haven't released the Paper 3 one on the site yet, and hopefully when I have some time I will release a Paper 3 prediction before you have Paper 2. After Paper 2 I will release a Paper 3 prediction, which is just all of the leftover topics that didn't come up in Paper 1 and Paper 2. Okay, so how does this work? If you haven't used this before, you can just watch this video and pause them at the start of each clip and try it and then see how I did it, or you can just watch how I did it and that's fine. If you want to have a go at it yourself, you go to onmaths.com completely for free and all of the papers are on the site there. It gets it to mark it yourself, gets it marked by itself, so it marks it for you. And it also gives you a grade at the end of the exam. And if you log in and sign up for free and log in, then it saves your scores. So you can come back to it tomorrow after a bit of revision and see if that's improved. There's also a whole load of other stuff on there. There's things called topic busters, which are just all the topics. So if you wanted to revise bounds or something, then go onto there and revise bounds. That's not a problem. There's also minute marks, which is just quick multiple choice questions where you pick a multiple choice answer and it comes up with an explanation of how to do it and tells you whether you're right or wrong. There's a whole load of other stuff on the site. All the stuff is completely free, so check out the onmaths.com website. But with no further ado, let's get started with the predicted paper for Paper 2 Edexcel Higher. Thank you. Okay, so this question's about an adult and two children. So we've got David Smith and two children. So there's one adult and 2 children. But the prices shown are not quite right because there's a discount. There's a 5th off adult price and 30% off the child price. So let's work out the adult price first. So a 5th off. Well, first of all, let's work out a 5th of £70. So to work out a 5th, you can just divide 70 by 5. Now I know that 10 fives are 50 and 4 fives are 20, so that's going to be 14. So that's going to be £14 he gets off. So therefore the price will be the £70 take away the £14. So 70 take away 10 is 60, take away 4 is 56. So he's going to pay £56 himself. Let's do the child price. Okay, so it's 30% off the child price. So we want to do 30% of £37. Okay, let's do the equals down here to give us some room. Well, I know that 10% is going to be £3.70, and then I need to times that by 3. Okay, so I could just times it by 3. Let's have a think. I could do 370. I could do it in pence, and then just times that by 3. So 370, and then I can just do times 3. So I can do a little grid. And if this is on the calculator, then obviously you just type it into the calculator. And obviously that's going to be 0, so we don't need that one. So that's 900. That's 21 with a 0. So 900 plus 21, 210 even. 0, 1, and then 11. So that's going to be £11.10. And so we want to work out the price. So it's going to be £37, take away £11.10. So if you take away 10 it's 27, take away 1 is 26, take away 10 is £25.90. Now that's for one child, so that's one child. So if I want 2 children, I want to do £25.90 times 2. Now I know 25 times 2 is 50, 90 times 2 is £1.80, so that's going to be £51.80. Okay, I'll move down a bit, and let's do the total. So the total is going to be the adult price, which is this one here, plus the 2 children price, which is that one there. So I want to do 56 plus £51.80. And again, if you've got a calculator, you can just type it in, but let's do the column method. £1.80, and then people like putting the zeros in. So that's going to be 0, 8, 7, 10. So that's going to be £107.80. So it's £107.80. Finished. I say you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this. And that will make a fraction appear on your calculator. Now, some of the older ones, the fraction looks a bit weird. It involves like a symbol like this. And actually on the new ones it can, but you need to change the settings if it does that. It should open up, it should look something like this, like a box and then another box, and there should be a cursor blinking in this box. Okay, so we want to fill in this top box first, since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, but like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19, and then to get the squared button, it's on like that. So you just press that, and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now, it might be tempting to try and round that, but it says it wants all the figures, so just put them all in. Now, if your calculator is set to a mode which it's going to show even more numbers, then normally six digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to two significant figures. Now, to do two significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting. And you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now, all of these numbers here are going to be reset to 0. They're going to go away. Well, not quite. Let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, 4, and then you'd think, oh, okay, that's it, rounded, and you'd write that in the answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line that I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0. And actually the other numbers do too. But these numbers here are not changing the number at all. These 2 zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400. Okay, because we don't need to show these numbers. Now, the reason students make this mistake is they're so used to decimal places. Now, decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. So this question looks quite complicated at first, but actually there are two very simple-ish ways of doing it. We've got 2 decagons, and so that means they are 10-sided. And you can just count the sides if you want, but if it says it's a decagon, I trust it, it's a decagon. Now what we can do is we could work out the interior angles of the decagons. Well, they'll be the same, so I can just work out 1 and then double it, and then take that away from 360 to work out A. And that's absolutely fine, that'll get you the right answer. A quicker way maybe, and especially on the non-calculator paper, but it works on both papers, is to draw a line up here and realise that you've got 2 exterior angles there. And the beauty of exterior angles for polygons is they always add up to 360. So to work out the exterior angle, always write down what you're working out. All you need to do is 360 divided by the number of sides the regular polygon has, and they have to be regular, otherwise you can't just divide them because we're assuming they're the same. So that's 36. So if that one's 36 degrees there, and that one's 36 degrees there. Then all you need to do is 36 times 2. Well, 6 times 2 is 12, 30 times 2 is 6, so that's going to be 72. So let's show the examiner that. 36 times 2 equals 72 degrees. So this question says there's a tennis tournament being played where each player plays each other once. And there's multiple ways of doing this. One of the ways is listing out all the different combinations. But this question only asks for how many tennis matches are being played. So you don't need to list them out, and sometimes you will need to list them out. This one you don't. So let's start off with a lyre. A lyre has 4 people that they're going to play against. William, Paul, Samantha and Christine. William, well, we've already counted a lyre's match with William, so William only has 3 left that he can play. Then Paul we've already counted his match with the other 2, so he's only going to play Samantha and Christine, other than his matches we've already counted. Samantha's only got Christine left to play after we counted all the other matches. And Christine's matches have already been counted so far. So we've got the 4 matches a lyre's going to play, 3 matches that William's going to play, not counting the one we've already counted from a lyre, plus the 2 Paul's going to play, plus the other one that Samantha's going to play. So 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. So in total, there are 10 different matches going to be played. Okay, so to begin this question, we need to understand 2 symbols. This symbol here is the union. It just means or. Now in a Venn diagram, that symbol will mean anything in the left-hand one or anything in the right-hand one. It's just anything within the Venn diagram. The second symbol we need to know is this one. And I always imagine that this has a little line here, and it's A for and. And means that both circles have to be true. So it's going to be this little one here. So it's where they overlap. Now, on question 1, it says write down one number that is in set A or B. So it can be in A, it can be in B, or it could be in both. So literally you can just pick any of these numbers here. So I'm going to pick, 5. The second question, it says write down a number that's in set A or B. Now, A and B. Now this is explicitly just these numbers. They have to be in both. So I can pick 11 or I can pick 3. Now for question C, slightly more complicated question, and introduces a third bit of notation. This symbol here, this little bit right here, means not. So we don't want it in A and we want it in B. So if I highlight everything that's not in A, so this is everything that's not in A, it's all this bit here, and then I highlight everything that it is in B, so it's this bit here. So we're looking for anything that's not in A but is in B. Now you can see where the 2 colours overlap. They overlap on the 26 and the 14. So the 2 numbers that are in that set are 26 and 14. So there are 2 numbers in that set. Let's just move this down a bit. So there are 2 numbers in the set, and there are 6 numbers in total. Now we know that that's also going to be the same as the third. Okay, so this question, it looks like a standard bearings question, but something you might notice is there's no angles in it. So if there's no angles in it, we need something else, and that something else is going to involve the right angled triangle here. So we can see there's a right angled triangle here, And we know that when we've got right angle triangle, we've got two sides, we can find an angle with trigonometry. I'm going to call this angle x. Now to find x, we need trigonometry, and to do trigonometry, we need to label the sides. So we've got the opposite here, which is opposite the angle we want. We've got the adjacent here, and we've got the hypotenuse here. Well, the hypotenuse is no interest. We're not looking for it, and we're not given it. So it's O and A. So writing SOHCAHTOA, SOHCAHTOA. Well, we're not interested in the H, so it's not going to be SO, and it's not going to be Ka, so it's going to be TOA. So TOA stands for tan x equals opposite over adjacent, and the opposite is 47 and the adjacent is 72. Now we want to work out what x is, so to do that we want to inverse tan both sides. Okay, let's just scroll down. Okay, so on the calculator you want to click shift or the equivalent on your calculator and then tan, and then you press the fraction button, 47, and go down, 72. Just don't forget to close the brackets. Every time you click tan or inverse tan, it opens a set of brackets. Just make sure you shut them. Let's press equals, and that equals 33.1356, blah blah blah. Okay, let's have a look. So x is 33, but we still haven't got a bearing. What we can do is work out what this one is, and I'm going to call that y. So to work out what y is, it's going to be 33.1. Well, we're looking for nearest whole number, so let's call that 33. And then we're going to add the right angle here. Now, the reason I know this is a right angle here is because it says that he heads west and then south. So I know that both the angle here and the angle here are going to be right angles, because the angle between all four, north, east, south and west, all four directions are going to be right angles. So I'm going to add 90. And you can do this in the calculator, or you can do it in your head. I'm going to do it on the calculator. 123. Okay, now bearings, something that we've got to remember, are always from north going clockwise. So it's always going to be like that. It's going to be that angle there. So to do that, we're going to do 360. And we're going to take away the 123 because that's what we don't want. So on the calculator, 360, take away 123, and that's 237. So the answer is 237 degrees. Okay, so tree diagram question, and this one says that in bag 1 there are 3 blue counters and 4 red counters, and in bag 2 there are 4 blue counters and 3 red counters. So with tree diagrams we always start here, and we ask ourselves, well, in bag 1 we can either pick a blue or a red. Well, let's start with blue. What's the probability I pick a blue? Well, there's 3 blues and there are 3 blues and 4 reds, so 7 in total. So we move on. We've picked a blue from bag 1, so we're currently here, and we look at bag 2. Well, in bag 2 there are 4 blue counters and 7 in total. Let's go back a little bit. Let's go back to if we picked a blue in bag 1. Well, we could have picked a red in bag 2. So there are 3 reds and 7 blues. Now let's go all the way back to the start, and let's pretend we picked a red from bag 1. Let's have a think. What's the probability? Well, there's 4 red and 7 in total. and a blue from bag 2, well, that would stay the same, wouldn't it? Because there's still 4 blues and there's still 7 altogether, and there's 3 reds and 7 altogether, and that would be enough to get you full marks. Let's move on to the second question. It says work out the probability that 2 counters picked are of different colours. So let's follow the paths down. If I pick this one, so a blue and then a blue, I've ended up with a blue and a blue. Well, they're not different colours. So let's try another line. So if I pick a blue and then a red, well, that's a blue and then a red. So we want that one. Let's start going down here. So I pick a red from bag 1 and then a blue from bag 2. Well, that's the one we want. And let's try the last one. So a red from bag 1 and a red from bag 2. Well, they're not different colours. So it's these middle 2 we're interested in. It's that one and that one. Now the way of working out the probability of ending on either of those is just to write down the fractions that you passed to get there. So I passed this one, so 3 over 7, and I passed this one, so another 3 over 7. And then what you do is you times them. Now to times fractions, you just times the tops times the bottoms. So 3 times 3 is 9, 7 times 7 is 49. Let's do the same with the red and then blue. So we passed a 4 over 7, and we passed another 4 over 7. And let's times them. So that's going to be 16 over 49. Now, this is the problem, is we end up with 2 fractions. Well, we need one answer. So we need to find some way of combining those together. And in probability, we use the word or. It can either be that one or that one. And any time you use the word or, what you're going to do with the fractions is just add them together. Now, the beauty of this is normally you're going to end up with lovely denominators that are the same. And when the denominators are the same, all you need to do is add the numerators. So 9 plus 16 is 25, and the bottom stays the same. So it's 25 over 49. Whenever we see a 3D shape in a question, you've got to ask yourself, is the question asking for a volume or a surface area? And that should be the first question that goes into your mind. Yes, it might be asking for something else, but those are the main two. We're looking at this, we're filling the swimming pool with water, so it's going to be a volume question. Now, way of approaching this is figure out what the shape is. Well, the shape is a trapezium-based prism. So we've got to first of all work out what the area of the trapezium is. So I'm going to draw the trapezium out first. And that height is going to be 2.7 that side, 5.3 that side, and 25 across. And I'll leave off meters because I know they're all in meters. But do check they are all in meters when you do this. So we've got to first of all work out the area. Now the area of a trapezium is half A plus B H. Now A and B are always the two parallel sides, and then the height is the one that connects them at right angles. So the height is going to be 25 there. And all you're doing is working out the average of the two bases, the 2.7 and the 5.3. We're going to times that by 25. Okay, so we'll crack our calculator out. 2.7. Some of you will probably see this straight away. So the first bit comes out as 4, because halfway between 2.7 and 5.3 is 4, and then times 25 is going to be 100. So the area is 100 meters squared. Now, for a prism, so volume, all you need to do is work out the area of the cross section, which is this bit here, the bit we just worked out, and then times it by how 3D it is. I think they call that the length officially, 15 meters. So the volume is going to be 100 meters squared times 15, which is going to be 1,500 meters cubed. So that's what the volume is, and it says the machine transports the water at a rate of 20 meters cubed per minute. So in 1 minute it's going to be 20, in 2 minutes 40. The other way of working this out, or the other way of thinking about this, is how many 20s are there in 1,500? So we can say time equals, so this is how much it's got to fill, and this is how much it does per minute. So on the calculator, 1,500 divided by 20, which equals 75 minutes. So it's going to take 75 minutes to fill the pool. Okay, so Boxplot question. Now, it might be tempting to think that the information here is all you need to plot on the Boxplot. Well, it's not quite that simple. The 8 is the lowest, so I can plot 8. And the lower quartile is 16, so that's fine. I can plot that. And the median 19, I can plot that. But then I'm not given the other two that I need to plot. So to work those out, I'm given the interquartile range is 4. Well, the interquartile range is the distance between the lower quartile and the upper quartile. And if the lower quartile is 16, then the interquartile range will tell us that the upper quartile has to be 20, because we just add that on. So it's going to be here. So I'm going to do my box. Now the range is the biggest, take away the smallest. So if the smallest is 8, then to work out what the highest is going to be, then I just get the range, which is 14, and add on to the 8. So 14 plus 8 is 22. So the highest value is at 22. There we go, and that's our box plot. So that's question 1 done. Or question A. Question B says, find how many students scored more than 20 marks. Well, 20 marks is our upper quartile. That means that 25% of the students scored more than 20 marks. So there are 140 students. So I just need to find out 25% of 140. And I can halve it, then halve it again, which is 35. So it's 35 students. Next one, question C. Estimate how many students scored less than 12 marks. So let's have a look at 12 marks. 12 marks is here. And 12 marks is halfway between the lowest value and the lower quartile. So we know there's 35 students who are in that quarter. And so we're going halfway there. Now we can't really say 17.5. That doesn't make much sense. So on this question, I would expect that you could either write 17 students or 18 students. And what am I going to say? I'm going to say 17 students. It doesn't actually matter which one you write down, because you've shown that it's 17.5, well, you can't get half a student, so let's go for 17, or let's go for 18. Right, when working with bounds, the easiest way of answering the question or thinking it through is just to do a quick number line, put the number that's been rounded in the middle, and try and figure out what the next one down is. Well, it's 10 nearest 5, so the next one down is going to be 80. Now we could do the next one up, but it's asking for the lower bound, so we're only interested in the lowest possible values. Now, next thing is to work out what the cutoff point was. Why was it rounded to 85 and not 80? At what point did it need to be higher then? Well, the point at which it needs to be higher is halfway between the two, which is 82.5. So that's our lower bound for the 85. Then just repeat the process for the 160. So we've got 160 in the middle. And the next one down would have been 155. And then when we draw the line, well, it's going to be 157.5. Now, what many students would do is just look at the number. Well, the area is going to be 85 times 160, and that's what the area is going to be. But we know that the 85 could have been 82.5, and the 160 could have been 157.5. And that would give the lowest possible area. So if I get my calculator out, 82.5 times 157.5, and that gives me 12993.75. And it doesn't ask me to round it, so I'm just going to write down the exact number. Now be careful, with areas we're timesing them, so we want them both to be small, but if you were to divide them, sometimes you actually want the upper bound of one of the values, but for area you want them both to be as small as possible to give us the lower bound for the area. The easiest way of approaching this question is to understand what multipliers are. Multipliers, you always start off with 100%. You work out what's happening, so let's say we're adding 40%, and then you work out the final percentage, which is 140%. The final thing you do is just convert it to a decimal, so divide by 100 to make it 1.4. That means you can multiply any number by 1.4 and it will go up by 40%. So in this question it says we have Billy, we have James, and we have Sam. And we're told that James collects 40% more sand than Billy. So he's got 40% more. We're told that Sam collects 20% more sand than James. So he's got 20% more. By what percentage has Sam got greater than Billy? Okay, now the obvious answer is 60, and if you write 60, unfortunately you're not going to get the right answer. The way of doing this, as I said, is to understand multipliers. So, we imagine Billy starts off with 100%, and he's gone up by 40%. So that means he's now got, James has 140% of what Billy has. Now, as a multiplier, that's going to be 1.4. So whatever amount Billy has, we're going to times that by 1.4 to get James's amount. Then, James then has the 100%. We add 20% on to work out what Sam has, which is 120% of what James has. As a multiplier, that's going to be 1.2. So we're going to times James's amount by 1.2 to work out Sam's amount. Now the problem is we don't know what the amount is, but we do know what we're going to do to it. We're going to times 1.4, then times 1.2. So if we get our calculator, or if it's a non-calculator paper, then you have to do this the long way. And I type in 1.4 times 1.2. And that will tell me in total what I'm timesing Billy's by to get straight to Sam's. Like so. The answer to that is 1.68. Now that's as a decimal. If I convert that back into a percentage, that means Sam, if Billy has 100%, that means Sam has 168%. So therefore, Sam has 68% more than Billy. Now, if you're adamant the answer is 60, you need to go through this, because this is why this is such a high topic. It's understanding that actually it's not going to be. And the government, with all their statistics all the time, use this, and people think, oh, it's 60%. It's not. It's 68% for this question. To solve a quadratic, first thing you need to do is get it equal to 0. So I'm just going to write it out first of all. And then I'm going to draw my lines down so I can show the examiner what I'm doing. So the first thing I'm going to do is take away 6x both sides. So it's going to be x squared plus 7x minus 14 equals minus 10. And then I'm going to get rid of that minus 10, so I'm going to add 10 to both sides. So it's going to be x squared plus 7x minus 4 equals 0. Now the first thing I do is look at it and go, can I factorise it? Well, given the fact that it wants an answer correct to 2 decimal places, that's a bit of a hint that you're not going to be able to factorise it. Because when you factorise it, you'll normally end up with a much nicer number. And if the coefficient of x squared is 1, you'll end up with an integer. So we're going to have to use the quadratic formula, and there are other methods, but the most common one is the quadratic formula, so that's what I'm going to do. So the quadratic formula says x equals minus b plus minus the square root of b squared minus 4ac over 2a. Now you might say to yourself, well, what is a, b and c? Well, hopefully you don't, because if you're doing this question, I would assume you do know what the a, b and c are. But for those of you who don't, a is the number before the x squared, b is the number before the x, and c is the leftover number. Now, the number before the x squared is 1, because there's no number there, so it's 1. The number before the x is 7, and the number on its own is minus 4, and that's really important that you understand that that's not 4, that's minus 4. So when I substitute it in, so b was 7, so it's minus 7 plus minus square root of b squared, well that's going to be 7 squared, so I know that's going to be 49, so I might as well write 49. Now it's minus 4 times a times c. Now a is just 1, so we can ignore that. Minus 4 times c, which is minus 4. Well, minus 4 times minus 4 is going to be a positive 16 over 2 times 1, which is just 2. Now you could, at this very early point, just type this into the calculator and that would be absolutely fine. Just make sure you put brackets around this and put any negatives in using the special minus button, which on the Casio calculators is 2 spaces above the 7. Okay, let's keep going there. So I might as well just type this in now. Well, I can finish it off. I can do the 49 plus 16 without a calculator. So let's keep going. Let's do it without a calculator for a little bit. So that's going to be square root of 65 over 2. Okay, this plus minus thing here just means that there's going to be a plus answer and a minus answer. So we split it up into 2 at this point. We have x equals minus 7 plus root 65 over 2, and we have x equals minus 7 minus root 65 over 2. And what you can do is just type that into your calculator, press the fraction button, then minus 7 plus root 65 over 2, and then you press equals, and that gives an answer for us. So I'm going to put that straight in, I think. No, I'm going to show the examiner, I know. I'm going to show the examiner. So 0.531128 blah blah blah. And then what you can do is, on the Casio calculators, you can just use the cursor button, which is the big blue round one, to move across, go to that plus, delete it, and change it for a minus. It saves you having to write the whole thing out again. And then let's have a look. And if yours comes up as a fraction or something, just press the S to D button. It converts it. That's minus 7.5531128 blah blah blah. Okay, it says to round it to 2 decimal places, does it? Yeah. So we want 0.53. So 0.53. What else? Minus 7.53. So minus 7.53. There's our answers. Now, this is a question about composite functions, and I'm going to start this question off by just answering this question. What is f bracket 4? Now, this equation here, up until this level, that used to be y equals 4x, and the question we have here would be, what is y when x equals 4? It's the same question, it's just a different way of writing it. So, all you need to do for f brackets 4 is feed in 4 as x. So that's going to be 4 times 4, which is 16. Okay, same answer as this, and it's the same question, just written differently. And at this level you need to be comfortable with function notation rather than y equals. Okay, now I said I'd ignore the g. The g says, oh okay, when you're done with f, g wants to do it as well. So what I should be writing is this, and I still have to apply a g to all of this. Let's get rid of that. And so I still need to apply the g to the 16. So we've done the f, and the f we did first because it's closest to the brackets. So whichever one's closest to the brackets you do first. Okay, we've done the f. Now we need to do the g, and we just do exactly the same thing. So g of 16, we're going to feed 16 into the equation. Well, it says 7 plus 2x, so it's going to be 7 plus 2 times 16. Well, I know 2 times 16 is 32, and I know 32 plus 7 is going to be 39. 39, okay. And so therefore the answer is just 39. Okay, perfect. Right, the next one. This time it's important to notice that the f and g are the other way around. So it's g that we're going to be doing first and then f. Now the thing we're feeding in is x. Well, you can't feed in x as x. Well, you can. It's just going to remain as x. So let's focus on the g first. So we're going to do g of x first. And now g of x is just given to us in the question. It's this bit here. So it's going to be 7 plus 2x. Now f wants to then use that 7 plus 2x and feed it into the f of x equation. So f of x is 4 times x. We're feeding in the 7 plus 2x, so it's going to be 4 times 7 plus 2x. Then we can expand that a little bit. So 4 times 7 is 28, plus 4 times 2 is 8x. Okay, now there's an equation here which I've kind of ignored up until now, but we need to write it now. So it says that 28 plus 8x, which is the fg brackets x, equals 52. So let's sort that out, solve that. So the first thing I can do is take away 28 both sides. And if it's on the calculator paper, you might as well use a calculator to double check your answer. If it's not on the calculator paper, I think most of you will be able to work that out. It's 24. And then we want to divide the 8. So we get x equals, so it's x equals 3. Okay, so the way of doing this question is understand that the 3 inequalities here, you're not going to be able to draw an inequality directly. What you do is you draw y equals 2, x equals minus 1, and y equals x plus 1. You need to draw those 3, and then you worry about the inequality afterwards. So let's start with y equals 2. So y equals 2 starts on the y-axis at 2, and it's just a horizontal line across. Now there is a choice. Before you get your ruler out and you draw it, there is a choice. If it can't be equal to the points on the line, then it has to be a dotted or dashed line, which shows, right, it can't be equal to this though. So I need to do this with a dashed line across, and that's our line y equals 2. And then when we shade it in, it will become y is greater than 2. So it says mark the region, so greater than, I'm going to get my red out, is going to be 3, 4, 5, 6. So it's going to be this bit here. Now what some people do is they shade in the region they don't want, and that's absolutely fine too. Okay, let's go on to the next one. X equals minus 1. So again, it's not equal to it. So it's going to be this line here, where x is always minus 1. That's our line y equals... Oh, get myself in a tizzy. Let's start again. That's our line x equals minus 1. Okay, and it's greater than it, so it's going to be all the way along here. So it's going to be the blue one. I probably shouldn't have these lines leave the graph, but I'll tidy that up a little bit. There we go. Perfect, right. Okay, so we've already got a little bit of a region going on at the top right, which overlaps both of them. But we've got one more line to do, and it's y equals x plus 1. Well, y equals x is a diagonal going through the origin, going from bottom left all the way up to top right, with the coordinates 0, 0, 1, 1, 2, 2, etc. And we're adding 1 to that. So it's going to go through this point here. It's got a gradient of 1, so for every one it goes across, it goes up 1. So it's going to be this line here. You don't need to plot all the points, you can get your ruler out after 3, but I might as well. So I started, so I'll finish. So it's going to be this line here. Now it's not clear whether we're shading in beneath it or above it. So let's have a look at the inequality. It says y is greater than or equal to x plus 1. Okay, so what I do normally is pick a point. I'm going to pick 3, 3. And I'm going to plug in both the values. So y is 3 and x is 3. So is 3 greater than or equal to 4? No. So that coordinate I picked, 0.33, doesn't work. So that tells me it's the other side. So it's this bit here that is part of that region. Now, it gets quite messy at the moment, but the region we're looking for is this region here. And it says mark it with an R, so I'll mark it with an R. Okay, and if you wanted to shade it in, then you can do. There we go, it's that bit there. Now you might notice that the y is greater than 2 actually doesn't make any difference to it. It normally will, but on this question it didn't. Okay, so a circle theorem question. With these questions, it's really important that you set all your working out and you give reasons for every step. So I'm going to do it one way, and there probably are slightly different ways of doing it. And as long as you give the reason, then that's absolutely fine. We're asked to find ODF, and just to help us, I'm just going to mark that on. So it's that angle there. Now, just finding this angle here, which we're going to start off with, it doesn't mean it's the same angle as that. You can't guarantee that the arrow is going to be symmetrical. So we're going to start off with this one. But how do I show the examiner that's the one I'm starting off with? Well, the letters are there so you can actually write down what you're trying to find. So I'm looking for angle OBC, and you could write the word angle or angle OBC, or you can just do a little angle on top of the B. And we know that that's going to be 90 take away 51, and the reason is that angle between tangent and radius is 90 degrees, and that's one of the circle theorems. So AC is a tangent, and OB, because O is the centre, is a radius. So the whole thing's going to be 90. So when I do that, so I'm going to do 90 take away 51, which is 39 degrees. So we know that that's 39 degrees. And it's absolutely okay to mark it on the diagram as well. And actually sometimes, not often, but sometimes the examiner will look at the diagram and might give you some extra marks because you didn't show the working out. But most of the marks for these types of questions are for the reasons, and you can't really show reasons on the diagram in a way that the examiner is going to be able to see it. So I also know, let's have a look what else I can work out. Well, that's also 90 degrees and that's also 90 degrees. And ADOB is a quadrilateral. So we can work out which angle we're going to pick next. Well, let's pick this angle here next. So what's that? DOB. So angle DOB is going to equal 360 take away 30 plus 90 plus 90. Okay, so I need to give a reason. Well, let's work it out first, and we can give a reason afterwards. So we're going to take away, what is it, 180 plus 30, so that's 210 from 360. That's going to be 150 degrees. And the reason is angles in quadrilateral. And we should really say that the angle ABO and ADO are angles between a tangent and radius as well, but I'm not going to. We've already used that reason, and it's clear in our diagram that we've just repeated the same reason. Okay, so angle DOB we've got as 150. So let's mark that on our diagram. So we can work out this angle here. Okay. And it's very difficult to know what to call this angle because we've already called DOB once. So we could call this other DOB. Let's go for that. Other DOB equals 360 minus 150. Okay, and the reason for that is just angles on a point. So that's 210 degrees, angles on a point. Okay, so what are we up to next? Well, we can work out this angle here, and actually let's mark on the 210 as well. So we've got it all on our diagram. We can work out angle DFB. So DFB, and this time we're using the circle theorem that says angle at the centre, which is the 150, is twice the angle at the circumference. So angle at the centre is twice the angle at the circumference, so it's going to be 150 divided by 2, which is 75 degrees. So angle at centre twice angle at circumference. Now, if your teacher's given you different ways of writing the circle theorems down, that's absolutely fine. There is no strict way of writing it down. So that's going to be 75 degrees. And if you look, we've got the arrowhead BFDO, which is a quadrilateral, and we've got 3 of the lengths. So we can work out ODF. I'm going to have to scroll up because my memory is not that good. So we're going to take them all away from 360. And what is it? 210, 75 and 39. Okay, so we're just going to take those away from 360. And obviously if you if you're doing this in the calculator paper, then please feel free to use a calculator. We get 36 degrees, and again it's just angles in quadrilateral. As a rule of thumb, my experience with these questions is they're normally looking for between 2 and 3 reasons. Obviously on this question there's an awful lot of reasons, but if you walk out of the exam and you just think, oh hang on, I only wrote down 3 and actually there's a 4th, sometimes you'll get the full marks, so don't panic too much. Just when you're doing the question, try and write down as many reasons as you can. Even really obvious ones like angles on a straight line or angles in a quadrilateral will help you get the marks. Normally, again, for circle theorem ones, they're looking for circle theorems as well as those ones. First thing I do with this question is just write the numbers out. They're a bit small in the question. Now with all sequences we're interested in what it goes up in. So we're interested in what these go up in. So if you've got a calculator you can just do 25 take away 13. If it's on the non-calculator paper then you can just quickly do it in your head. And I'm going to do this for a few of them. Now you might notice straight away that the next one goes up in 18. Well, let's have a look at the next one. That goes up in 24. And the last one goes up in 30, which is what we'd expect. So they're not going up by the same amount. Now when they don't go up by the same amount, we need to have a look at the second difference. If they don't go up by the same amount in the first difference, that means it's not going to be an arithmetic sequence. We're not going to use the standard linear nth term, the one that you're probably used to. For a second difference, it's going to be a quadratic. Let's check to see if there's a second difference. So that's add 6, this is add 6, and this is add 6. So we know it's a quadratic sequence, so it's going to involve an n squared somewhere. Right. The step that people have difficulty with is you get the second difference and you halve it. And that's all you've got to do. Now, that halving, the dividing by 2, won't ever change. You'll always halve it and you get the number 3. This 3 is going to be the coefficient of the n squared. So I can fill that into my answer now. Now, the problem is we don't know what else we need. What we need to do is write out the sequence 3n squared. So let's number the terms. So we've got the first term, second term, third term, fourth term, and fifth term. And so we've got our sequence, which is, I'm just going to copy this out again, 13, all right, 35, it's 25. 43, 67 and 97. And we're going to write out the 3n squared which we've just discovered. Now that means we just square the sequence number and then times by 3. So 1 squared is 1, times 3 is 3. 2 squared is 4, times 3 is 12. 3 squared is 9, times 3 is 27. 4 squared is 16, and times that by 3 is going to be 48. 5 squared is 25, times 3 is 75. Now what I want to do next is I want to subtract them. I want to subtract the sequence, I want to do the sequence take away the 3n squared. We know that 3n squared is a part of it. We need to just take it away so we know what's left. So 13 take away 3 is 10. 25 take away 12 is going to be 13. 43 take away 27 is going to be 16. 67 take away 46 is going to be 19. And 97 take away 75 is going to be 22. Okay, now we end up with a little sequence here. Okay, we've got 10, 13, 10, 13, 16, 19, 22. Now we find the difference in that. So that's a plus 3, plus 3, plus 3, plus 3. Now that's a linear sequence. Now we've got to find the nth term of it. So to do that, we find the 0th term. So we go back 1, we subtract 3, and that tells me, so I'll say linear. So that's going to be a 7. So we know we're going to add 7. And we know it goes up in 3, so it's going to be 3n plus 7. So we got our 3n squared already, and we just need to add 3n plus 7. So the first thing you need to do is find out what the quadratic sequence is, the quadratic bit of it, the squared bit. Then you've got to find out what the linear bit of it is, and then just add them together. To simplify a fraction, you need to divide top and bottom by something. So if I just try and divide top and bottom by something now, I need to find something that all 6 terms have in common. Well, there is nothing that all those terms have in common. So the way of starting this is to factorize the top and bottom, so put them into brackets, and then something will turn up. So let's factorize the top. So I know it's going to be x at the start. I need 2 numbers that add together to make 12 times together to make 35. Well, that's going to be 7 and 5. Then I need to factorize the bottom. Now, a little bit of a cheat here. I know one of them will be the same. So either one of them is going to be x plus 7 or one of them is going to be x plus 5. So I need 2 numbers to add together to make the 10x times together to make 21. Well, I know that 5 doesn't go into 21, but I know 7 does. So x plus 7 and x plus, well, to make the 21 and the 10 needs to be 3. And all you need to do is divide top and bottom by, let's do it top and bottom. Get rid of that. So all I need to do is divide top and bottom by x plus 7 even. And what that does is just gets rid of that and gets rid of that. The fraction stayed the same, but now it's x plus 5 over x plus 3. This seems like quite a complicated question, but if you break it down into steps, it's much, much simpler. We need to find out, first of all, what the area scale factor is. Now, it's important that you realise that there is a linear scale factor, an area scale factor, and a volume scale factor. To work out the area scale factor, I'm going to get the 1731, which is the new size, and divide it by the old size, which is 2328. So I'm going to get my calculator, and 1731 divided by 2328. And when I do that, I get a horrible decimal. Now you can write it as the fraction that turns up, which is 577 over 776. Or you can write it as decimal, but keep it in your calculator, because the next step is to work out what the linear scale factor is. Now, there's no linear involved in this, but we need the linear one to then find out what the volume scale factor is. Now, to find a linear scale factor from an area scale factor, all you need to do is square root it. So I'm going to square root 577 over 776, or I've just kept it in my calculator. So what I'm going to do is press the square root button and then just answer, which is at the bottom of the calculator, bottom of the Casio calculators. Press equals, and it now gives me a decimal of 0.8622, blah blah blah. And when I do the little dashes at the bottom there, I'm showing the examiner that I'm going to keep it in my calculator. I'm not going to round it. Right, so we need to work out the volume scale factor. Now, to find the volume scale factor from the linear scale factor, you just cube it. So I'm going to show the examiner that I'm going to keep it in my calculator, but I'm going to cube it. So what I'm going to do is just press the X with a little square button, and then 3. Or just press the X cubed button. Let's have a look. And that's going to be 0.6411. And again, I'm going to keep it in my calculator, because the last step is to find out what the new grams is. Now, the reason we need the volume scale factor is grams is a 3-dimensional thing, okay? So it's going to be involved in the volume. Yes, with volume normally it's centimeters cubed, but grams works the same way as centimeters cubed. So to work out the new weight, I'm just going to get 319, and I'm going to times it by that 0.641 blah 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 blah. So on my calculator, I'm just going to times it by 319, and I get the answer of 204.5322 blah blah blah. It says it wants its 2 decimal places, so 204.53 is going to be my answer. Looking at the structure of the answer, it looks very much like we're going to have to complete the square. Now, to complete the square, we need x squared minus something, okay? Now, we've got 2x squared, and so minus something x. We've got 2x squared minus 28x, so we're close to getting that, but we haven't quite got that. So what we need to do is factorize the 2 out first. So 2 brackets x squared minus 14x. And then I'm just going to add the minus 4 at the end. You could also factorize out the 4 as well, but I'm just going to leave that alone because I'll deal with that later. Now that we've got what we need to be able to complete the square, which is the x squared minus something x, we are going to complete the square. Now to complete the square, and I'm going to do this over here to show you a little bit easier. What you need to do is you need to put the x minus half of the bit here. So it's going to be 7 squared. Now that will get, if you expand that, that will be, or using FOIL, that would be x squared minus 7x plus 49. Now we need the x squared, we need the minus 7x to get the minus 14x, but we want to get rid of the plus 49 that it generates. So we need to take away 49 from it. And that's it, that's completing the square, okay? So I'm going to replace that with what I've just found out that it is, x minus 7 squared minus 49. Now, I have that minus 49 on the inside of the brackets, and I want to collect that with the minus 4 on the outside of the brackets. So I'm going to just expand the big brackets. So I'm going to times the x minus 7 squared by 2. And I'm going to times the minus 49 by 2. And so I can collect the numbers together. So looking at the question, it says it wants m. M is the thing before the brackets, so m is going to be 2. Now it says that p is a positive. Well, we know that p is minus 7, so I'm going to put minus 7 there. And q, it says, is a positive. Well, we know it's a negative, so it's going to be negative 102. This is a question about iteration, and question A is a little bit harder maybe than the exam will go, where it asks you to come up with your own iteration formula. So, in order to do this, it says that fx equals 0 for this formula. So the first step is just to get it equal to 0. Now the question's given you a hint because it says that it involves a cube root. So we know that we're going to have x cubed equals something, and then we're going to cube root both sides. So I'm going to just put my lines down. And we're going to add x and add 5 both sides. And we're just going to cube root both sides. So our iteration formula is going to be the cube root of x plus 5. Now, with the iteration formula, it's a beautifully simple idea that this formula will, as long as we just keep ploughing in what we've found for the answer before, it will get us closer and closer to the real root. Now, sometimes the roots are infinite, so we could be sitting there all day and it will get a closer and closer and closer answer. This is why the question will say, 3 decimal places or 4 decimal places. So that will tell us when to stop. So it always will give you a first one, okay, the x0, the first one to try. And all you're going to be doing is putting that 1 into this formula here. Okay, so let's try it. So cube root of 1 plus 5. And that gets me 1.81712, blah, blah, blah. Okay, now I need to keep that answer. So what I'm going to do is I'm going to press the cube root button. Then I'm going to click inside the root. I'm going to click answer plus 5. And the calculator will remember the answer to the one we had before. Now, if you try and round them, you will get very, very different answers, and it might take you a little bit longer, or you might make a mistake. So you let the calculator do all the remembering for you. Then I press equals, and I get 1.89612, blah, blah, blah. So I'm going to do the same again. So I'm going to do the cube root button, answer plus 5. And we've got 1.9034, blah, blah, blah. Cube root button, answer plus 5. And we've got 1.9040, blah, blah, blah. Now, we're looking for 3 decimal places. So the numbers we're looking for being the same is these ones here. Now, we've almost got them the same, but we're not quite there, so we need to do another one. So cube root, answer plus 5, and we've got 1.9041, blah, blah, blah. Now, even if you were to carry on going, the first digits, the digits I've circled with I've put a red square around, are going to remain the same. So as soon as you get 2 that are the same to 3 decimal places, that is your answer. So my answer is going to be 1.904. Now, obviously we haven't got it perfect, but if you carry on the iteration, you won't ever get anything different to 1.904. The only numbers that will change are beyond that. So that's why we can confidently stop now and say, yes, that's our answer. Okay, so this doesn't seem like the easiest questions because there's 3 shapes going on. There's no numbers in it at all, and we're asked to find a formula. So the first place I'd start is working out, well, first of all, what are the formulas we'll need? Well, let's have a look. So we've got a hemisphere. And some of these formulas you will be given. So a hemisphere is a volume of a sphere and then halved. So instead of 4 over 3, I can just say 2 over 3, which is half of 4 over 3, pi r cubed. The cone that we've got is going to be 1/3 pi r squared h. And then the cylinder we have is the area of the circle times the height. Okay, now we need to find out what the bits are. So for the hemisphere we just need r. Well, that's quite simple because r is just going to be x. It's the radius of the hemisphere. Okay, now what's more difficult is to work out the height of the cone. Well, if the radius across to the right is x, the radius of the circle up is also going to be x. So we know the height of the cone is going to be 4x because one of those x's is used on the hemisphere. We know the radius of the cone is going to be x because it's stated at the top. So let's keep going. The radius of the cylinder is going to be 10x, and the height is just labelled as h. So that's nice and simple. Okay, now let's have a look at what this question's saying. It's saying that this thing here is going to be melted down and is going to be used to create this. So that's just saying that the volumes are going to be the same. So if I add the volume of the hemisphere to the volume of the cone, it should equal the volume of the cylinder. Okay, so we know that hemisphere plus the cone volume, and I should write volume here, show the examiner that I'm working with volumes, equals the volume of, I don't know why I wrote an S, my goodness, C for cylinder. Wow. Tell my maths teacher. Right, cylinder, there we go. So hemisphere is 2/3 pi, and we said that x was the radius, so x cubed. Brilliant. So plus the cone. Now, what did we say the height of the cone was? We said the height of the cone was 4x. So it's going to be 1/3 pi x squared, because the radius is x, and is it 4x? Let's double check that. Always double check. Yeah, it is. Okay. So the cylinder, and I'm going to leave that up so I can see it, is pi, and what's the r? So pi times 10x squared, and all of that squared, because all of that is r, times the height, so times h. Okay, so this is the formula we've got to work with. I'll put my lines down. Okay, so what we got? Let's sort out the timeses first, and let's tidy this up. So that hasn't got any timeses in it. This we're timesing it by 4, so it's going to be 4/3 pi, and I'm timesing it by x, so that's going to be x cubed. This one, I'm doing the 10x squared, so I need to square the 10 and the x, so it's going to be 100. And let's do the pi next. Pi, and it's going to be x squared h. Okay. Now, if you notice on the left-hand side, these two here are the same. There's both pi x cubed. So we can just add them together. So it's going to be 2/3 plus 4/3. So that's going to be 6/3, or just 2. So it's going to be 2 pi x cubed equals 100 pi x squared h. Brilliant. Okay. Now let's just check to see what it wants. It wants a formula of h in terms of x. So it wants h equals. Okay. So first thing I need to do, well, let's have a look. What's easy to do? Well, what's easy to do is just divide both sides by pi. Let's get rid of the pi's. So 2x cubed equals 100 x squared h. Now we want h on its own, so we're getting close. We need to divide by the x squared first to get h on its own. So I'm going to divide by x squared. So we get 2x equals 100h. So we can already see we're really close. So to get h on its own, we need to divide both sides by 100. and that's going to be 2x over 100 equals h, or h equals, and we can cancel the 2 and the 100, we can divide them both by 2, equals x over 50. So our answer is h equals x over 50. Well, I hope you enjoyed that paper, and I hope you found it useful. Don't forget, if you go onto onmaths.com, you can have a go at it online. We're going to be looking at hopefully releasing the paper 3 prediction before paper 2, but we definitely will afterwards, so please check out the site. Just continue. It will be on the site before I make a video for it, and hopefully I'll have time to make the video for it, but if I don't, it will definitely be on the site, sitting there ready to go. And check out the site for everything else on it. So if there's a topic that came up just now and you thought, oh, I'm not quite sure about that one, there will be a topic buster on it. We have topic busters for every topic in the GCSEs. So check out onmaths.com. Everything there is completely free, so you don't have to pay for anything. And I think we're the only site that does completely free. I'm not sure. Who knows? Maybe we are. So thank you very much. If you like this video, please click like. If you really like this video and want to check out more videos that we're going to produce in the future, please click subscribe. Thank you very much.